In a previous lecture I discussed type definitions using the typedef specifier, and with that we can create an alias for a known type. I have an example of the syntax right here. This again is useful for complex types, and it's just an alias, not a declaration for a new type. Now we can also declare an alias for a previously defined type with the using declaration. We do this with the using specifier or keyword, followed by the alias identifier, followed by the assignment operator, followed by the known type. So this is really easy to read, and as with the type definition, it is just an alias, not a declaration for a new type, and really there's no difference between the type alias and the type definition, but you may prefer this type alias for readability. We've seen this using keyword before with namespaces, and it's used in quite a few places, including with this with the type alias. And before I show you a quick example in Visual Studio, we can see the syntax comparison for the type definition and the type alias. As you can see here, the type alias reads really easily because we have the using, then the alias identifier, the assignment operator, and then the known type, whereas the alias identifier is typically right at the end, at the statement for the type definition, as we can see in the first statement. Again, for readability, it may be best to stick to the type alias because, as we'll see in future lessons where we have really complex known types with templates and so on, or where we have pointers to functions and so on, then the type definition with the typedef can get a bit complicated and a bit difficult to read, and it will be easier to read the type alias with the assignment operator. A quick simple example in Visual Studio, we can see we have the typedef right here, the type definition, and then the type alias with the using keyword. Both of these have the alias identifier ul long, okay, for unsigned or long, and this is easier to read, right? We have the assignment operator, you have the alias name firstly, and then you have the assignment operator, and then we can see, okay, this is the type. And I use that in the main function. I declare a variable called distance that is of this type, okay, which basically is short or an alias for this type. And I assign that some value, just some random value here, and I print that out. And that works fine. The type alias is declared in the global scope currently, but we can also declare it in a local scope. I'll move the type alias within this print function right here. And then we can see this identifier is undefined, this type alias is undefined. That's because it's within the scope of the print function. If I uncomment this, there's a type definition up here, then this will work again in the main function. And just to show you, I'll build around that. You can see that works. And of course, it's the same thing with the type definition as well. So I'll comment out the type alias, move the type definition within a local scope of the print function, and then it's not going to be available here in the main function. Okay, if you try and build that, you'll get an error. ul long is an undeclared identifier. And of course, a local type alias or a type definition will be handy if you want to avoid identifier conflict. Okay, so I just wanted to mention in this lecture that we also have a type alias, which is basically the same as the type definition, but as you can see, we use the assignment operator, and this may be better for readability, especially once we have more complicated types. And we'll talk about these again in the future when we actually get to those more complicated types. To wrap up this lecture, I'll do one more demonstration. So I have the type alias right here, and I'll add a global variable x, which is of type unsigned or long, and I initialize that to 55. Now let's say we want to go and do something like this. We try and do a type alias and we want to assign x to that. This is not going to work because x is not a type name, but if you think back to what we've discussed before, we can do. There's a declaration dec_l type. Now the type will be deduced correctly for the ul long. For example, right here, Control-K, Control-I, and we get the correct type for u long. It is of type unsigned or long, and this is useful. This sort of method here is useful if you have some complicated type that may be returned from a function or something like that. Okay, and with this, we are going to wrap up this lecture. I hope you found it useful, and I'll see you next time.